Okay, we're still grading lab test 1. You will know the result. The TA is now looking into your submissions. Okay, so but now I would say you want to worry about lab test 2, which is happening next Friday, right? Not this Friday, but next Friday. For those of you who haven't really paid attention to the course forum, lab test 2 has been, preparation guide has been released. It's going to be about ETF, and you have to learn about a pattern called undo redo. And you have to look into chapter 21 for OSC2. So this textbook is free. You can just go to the course wiki site and log into SVN to get it. You want to start with this as soon as you can and ask me questions, right? It's going to be the lab test 2. Okay, so now I will move on to design patterns, but before that I would like to give a little bit quick picture about generics. Let's spend maybe the first half an hour just to finish the story. Because later on when we talk about design patterns, not only that we're going to use polymorphism, dynamic binding, but also we're going to use generics. Okay, let's do that quickly. Let me bring you up to speed from last Wednesday. Last Wednesday we talked about this so-called general book. Basically you got something like that in Java as well. Basically like an array of objects. So we simply say an array of any. So the idea is you can store any record inside the book, including phone number and also birthday. Basically store anything inside, that's allowed. On the other hand, things always come with a price. Since you can store anything statically, that means when you want to retrieve something from the collection, it can be anything as well. You just don't know which one it is. This is why when we talk about last time for this particular line, okay, let's review this line very quickly. If you look at line number 8 over here, okay, now anybody wants to tell me very quickly again, which part of line number 8 does not compile? For what reason? Yes? Say it again? The .get will give you any. Yes, correct. Correct. Very good. Thank you. So basically, it's really important because when you look at this particular expression over here, b.get, as far as the compiler is concerned, b.get is going to look up this particular feature in the book class, which is going to return statically any, which means statically, the static type of the return value is simply just any. So now the question is this particular feature supported in the any class? The answer is no, because it goes like this. Any is at the top of the hierarchy, and then you also got a class called date over here, and only the date class support this particular feature over here. So this one is not going to compile. Even though we are so certain that since we say we want to get a record for Yuna, and for Yuna we actually put in her birthday over here, even though we are so sure. So now for us as a designer or implementer, we do have the power to force the compiler to believe. In this case, we can do a cast, right? So now, what can we do over here? Basically, if you look at the slides, let me just show you very quickly the syntax, and then we're going to talk about the design. That's really the focus for this lecture here, okay? So now, okay, that's the same example here. Okay, you can review them the same. And we know that line number 8 got some problem over there. Now, how can we solve the problem so that the compiler is going to be happy? Well, do a cast. Because we are so sure b.get dynamically is really attaching to a date object, so we can do a cast. So what we can do exactly is like this. Okay, so now what we can do is, okay, so this slide here basically just talks about whatever I just discussed. Why there's an error, okay? I don't need to repeat. On the other hand, how can we save us from the compile time error? What you can do is b.get Yuna, we are so sure it should be a date object dynamically. So we'll cast that into dates, and then we create a temporary variable over here, Yuna bday. And the static type for this particular new variable is now the dates. That is why we can say Yuna bday.get day of week, and then do it. Okay, that's something we did previously in the polymorphism lecture and cast, right? Any question about this? We okay, right? Yes. Good question. I believe that might be the next point. Let me just see. If not, I will respond to your answer. Okay, exactly. Good man. So what if the dynamic type of the return object is not a date? For example, if I try to say b.get, okay, let's say rather than Yuna, I would say Suyang over here, b.get, and then I would say Suyan over here. As you can see, what we put in for Suyan is actually a string, the phone number. If you try to cast that into a birthday, it's going to run into some crash, class cast exception, right? That's what we said before. Okay? So now if you go back there, basically this class is simply not appropriate. So that means you're going to run into runtime error. So that means the cast notation over here, on the one hand, is very powerful, because if you really know what you're doing, it's going to cast it into the right type. On the other hand, when your program gets very complicated, it might cast it into wrong type, which will give you class cast exception. Okay, that's a catch. So now, let's take it from there. We want to think about, since everything works with cast, now we want to see if there's any potential problem over here. Okay, so now again we talk about design, right? Basically, the design we had so far, we have a book of any. We can store anything into the book. And we can see that it will work if we got cast at the runtime, right? To cast the runtime object into some certain type. So what can be the potential problem as far as design is concerned? Let me give you a little bit hints. Or maybe you should say first before I give you the hints. Go ahead. Well, no, not really. If you change the, let's say, if you want to change the name of the class, let's say from dates into date 2, for example, you can systematically rename them. It's not a big issue. Let me give you guys a little bit hints. Single choice principle. Single choice principle. It might be, this one is a little bit abstract in this case, but single choice principle still applies. Okay, anyone? Okay, this is quite a big gap. Okay. So now I want you to imagine the following scenario. Let's say we have a book with 100 records. Each one of them is of different type. Maybe we got binary search tree, we got reblect tree, we got book, we got registry, we got many object types over there. We got 100 different types. So now, every time if you retrieve an object from there, what should you do in order to decide what operation to perform? For example, if the object that's being retrieved happens to be a binary search tree, you can do some rotation. Before you do the rotation, you have to cast that into binary search tree. If the object happens to be account, you want to do deposit, you can only do deposit after you cast it into account. So that means you have so many casts to do. And how many times are you going to do the cast, basically? Actually, many times, because every time when you want to define any command or query that has to do with retrieving an element from the collection, you have to repeat that kind of similar checks. You got so many repetitions. So you violate a single choice principle. If somehow you change the number of types in the collection, you got to modify all your definition for the cast. Okay? That's a very abstract idea. Okay, let's give you a little more concrete idea, a little bit more. So this actually motivates us. Having a book of any is simply not a good idea, even though you can make it work programmatically. But we talk about design. Let's talk about what can be a good design for that. Okay? So what we'll do is, okay, the hints over here, extendability, maintainability, okay, anyways, that's fine. So dynamic types basically can be anything at the runtime. So what we really want to do is, let's think about this. Let's say we got 100 different record objects in the book. Let's say we got 100 different ones. Okay? And for convenience, let me simply say I got record 1 of type C1, and up to I got record 100 of type C100, right? Just symbolically, right? We got 100 different classes. Let's say these classes have nothing to do with each other, okay? Just independent classes. And now, if I simply create, let's say for C1, for record 1, I simply create dynamic type C1, and then add it into the book. Do the same for record 2, all the way to record 100. So now I do have 100 records in the book, in the collection. However, every time when I retrieve any element from there, what is the static type? Just any, right? Okay, just remind you about it. Every time when I try to retrieve something from there, it's still going to be any. Okay, just any. Okay, I don't know whether it's C1, C2, or up to C100. Okay, just to make sure you follow that. Okay, after this, what I will do is, so that means every time when you want to define any feature that has to do with, I want to do something about the return value from the collection. Okay? You cannot get away from having an exhaustive check like this. I might say if, for example, if let's say I want to say b.get a particular key value, let's say Jim. However, statically, b.get will just give me any. I want to say if that can be cast into C1, I can cast that into C1 and then do C1.f1. Let's say f1 is only available for the C1. Okay? Okay, I can also do all the way to C100, right? I can say b.get if there happens to be C100, and then I can also do it and then cast that and then call f100. So this is kind of the exhaustive line of checks you have to do. And also got to keep repeating them. Are we okay so far? Yes, go ahead.
I have a question. This may crash. This may decompile because like any is an ancestor of C1.
Oh yeah, exactly. Yeah. Good question. So basically, let me explain something very quickly. Yeah, you're right. In this particular case, we are simply trying to cast, right? You would say check basically like a cast. You want to cast that into C1 all the way to cast to C100. Maybe only one of them will succeed. All the rest will just fail. Maybe really, I can improve the slide a little bit. I think what I really meant to write was something like this. Let me write it down. We'll see something very similar a little bit later. Okay, over here. Basically, what you want to see is, you can also say if, remember the attached expression is just a Boolean. I can say if attached over here, and then if there's an instance of, basically. And then I can say b.get, and then I would say Jim. If this is possible, remember this part here is just going to give me either true or false. If it is true, that means it is safe to cast. Okay? If that is okay, I can say check, and then attached. I agree the syntax might be a little bit reverse, but just one way to doing things. The same thing that you can do in Java. And then I can cast that into b.get, and then Jim, and then as, some variable over here. And then once I do the cast, I can refer to this particular variable over here, right? Okay? And then, of course, you can repeat this for as many times as you like, depending on the types. Okay? You gotta do this exhaustive check for so many times. Do you want to do it? Maybe not. If you like doing it, that's okay. Feel free to do it in your project, but it's not a very good design. We want to do a way that really deserves, right? Actually, you know what? Pay attention to this particular structure. We're going to see this not in the coming pattern, but the next design pattern. Okay, we're going to see that again. Okay, okay, that is something we really don't want. This will work, but violates basically single choice principle. Because let's say if somehow we change the way we organize the book dynamically, rather than from C1 to C100, maybe it's now from C101 to C200. The dynamic types simply just change, right? You got to reorganize all the dynamic types over here in every place that you talk about this exhaustive list. Okay, so that's a violate single choice principle. So now the question is, how can we fix this? What would be the good design to actually fix this? So now we want a solution that will satisfy the following criteria. Let's just go over the criteria very quickly, and then we'll show you too. Okay? Basically, we want to avoid cast. Also, we want to avoid having to say b.get, but we just have to do a cast. Right? That's something we want to avoid. We want to eliminate runtime assertion and violation. We don't want to get any class cast exception. We want to make sure we don't have to decide which type to cast into. Somehow, rather than having runtime assertion error, we want the compiler to tell us statically whether you can do this or not. Okay, that's number one. But how can we do this? That's the question. Number two, you don't want to have explicit check, attached check like a cast, or like an instance of in Java. By the way, the way we move from array of objects in Java into Java generics follow the same reasoning, the same. Okay, I'm just using a different language to illustrate the concept to you, the same. So now, how can we satisfy these two concepts? The answer is generics. Generics address exactly these two concerns. It's just that the way we talk about generics was mainly about code reuse in the beginning of the semester before the reading week. But now, we're going to dive a little bit deeper into the issue. So now, can we just keep these two principles in mind? Let's see exactly how generics is going to solve these two problems statically. So now what I want to show you is over here. Okay, by the way, what we just showed you was the general book, right? Now I want to show you a different design. Basically, it's solving the same problem, but now we got generics. Okay, that's something we want to see. So now let's see, I'm going to highlight exactly the difference to you. First of all, you can see for the class over here, in the case of generic book, we have to declare at a class level a type parameter, as many parameters as you like. Okay, and as opposed to in the case of general book, we simply say book. Okay, you can see a little bit more work to be done on the supplier side. Okay, basically we just parameterize this G over here. Okay, one analogy I want to show you very quickly. Okay, you can think about the way we having generic parameter over here is like this. Let's say mathematics. If you somehow want to define the operation called plus, like a binary operator for addition, right? You have seen so many examples, like the 3 plus 4, you got maybe 6 plus minus 2, and also you got 7 plus maybe 6, right? You got so many examples over here. The way to abstract this away is by saying, I'm going to define an add feature over here, and then I'm going to have first operand and second operand both being integer, and also it's going to return the integer. And then the way I'm going to define over here is, rather than having concrete example to be manipulated, we'll simply say x plus y. Okay? That's exactly what we're doing for generics. Rather than working with just any, we work with the parameters that we declare at the class level, which is G. Okay? You can see once we declare this G over here, you're going to use it for as many times as you like. For example, this is the first use. So now the records over here at the supplier side used to be, we simply say an array of any, but we don't say that anymore. Now in the new design, we're being more flexible as a supplier. We say that the records is going to be an array of something. That something there depends on how you instantiate the G to be. Something like, if I want to do this particular operation over here, 3 plus 4, I have to instantiate the x over here by 3, the same idea. Okay? Are we okay so far? That's its first use. And then also we say when we try to add, I simply say I just going to take the G that I declare over here. And also for the get, I will also to say return the G that I have over here. Are we okay so far? It seems like supplier has to do a little bit more work and also manipulate things in a little more abstract level. Rather than working with just any, we're going to say work with G. What is G? G is just any parameter. And of course, doesn't have to be called G. It can be any symbol that actually does not clash with any existing classes. For example, you might say just H, and H over here, and H over here, and H over here. That will also work. Okay? As long as you use a symbol consistently. Are we okay? Okay, hopefully. Okay, if you got questions, just let me know. So now, that's about the supplier side. Of course, you can declare as many generic parameters as you like, but now let's look at the client side. The client side is also fundamentally different. If you look at the client for general book, let's look at this line specifically. When I declare a general book as a client, I simply say B of type book. Over here, I'm not specifying what kind of elements might be stored in the book, because anything can be stored. On the other hand, since that we are requiring a generic parameters at a class level for the supplier, for you as a client to use this particular book, you have to specify a type. You have to. Okay? For example, over here I say B is of type book, and then I'm saying G is going to be instantiated by date specifically. So what does that mean? It is as if we do the following. So as soon as I say date over here, as a client over here, date, I'm going to replace every, okay, that means it's going to be instantiated by dates. I'm going to replace every occurrence of the G over here by date. It's as if I did that. Okay? It's actually a little bit more work for both the client and the supplier. The extra work for the supplier, number one, you have to declare the generic parameter at the class level. Number two, you have to work with that particular type, for example, G or H or K or V. For the clients, there's only one additional stuff. You have to make sure when you declare the book, you want to commit to it about what G should be. Right? It can be a date, or it can be, for example, let's say this. If I have something like this, so this is B. Let's say I got another client. I can say B2. If I say book over here, I can say address. It's a different client, right? So that means I'm committing to a different type. Do these look familiar to you from Friday? Maybe? If you don't want to record the experience, that's fine. Anyway, so here for B2 here, so what's the difference over here? You can see for B and B2 over here, B here and B2 over here, there are two separate usages for the book. The first case, we simply instantiate the generic parameter type to be dates. In the second case, we are instantiating that by address. So two different usages, right? So now, let's just go back to the first one over here, the first one, okay? Of course, you can create the book over here. You just have to repeat whatever type it is, okay? So now, it's really critical now. Again, I want you to reconsider a few lines. I'm going to highlight them for you, okay? I want you to consider, number one, this line here. Number two, this line here. Number three, this line here. I want you to reconsider these three lines. They look basically the same as the general book, okay? Now, since we have done some extra stuff to improve the design for the supplier and the clients, now, let me just number them quickly. So now, if I say over here, let's say this is number one, this is number two, this is number three. 1, 2, and 3. So now we want to know which lines will compile, which lines wouldn't. Is it going to be the same case as previously, or is it going to be different? Different. Let me give you a little bit of hints before you try to respond to me, okay? This is the essence for generics. Rather than being so tolerant on storing anything into the book, we're now being much more selective. Given that the clients already commit to what kind of types of the objects can be stored into the book. It has to be a dates. Okay, you want to say something? Yes. So now, which line do you think is not going to compile? You think 3 is not going to compile? You know what? If you think line number 3 is not going to compile, then we are not really improving anything. Because it also didn't compile in the previous design, right?
We'll return the right thing, but can't really guarantee it's
Okay, that's fine, but if that's the case, then we are not really improving anything, right? How about Adam?
Line 1 will compile, but 2 and 3 will.
Okay, you're saying 1 wouldn't compile over here. So now, good. So the answer is 1 will compile. Sorry, the other way. 1 wouldn't compile, but these 2 would. Okay, let's see exactly why, quickly. Okay, number one, first of all, when we are calling this add feature, we know that the context object is B, and B was previously declared to be book of dates. I'm following exactly how the compiler is going to check your code, exactly. Context object is B, which was declared a book of dates, which is as if we replace every occurrence of G in the original class by dates. Specifically, we know that for the add feature over here, when we add, it's going to accept the record to be date only. More precisely, it's going to be either dates or its descendant classes, right? Remember feature call argument polymorphism, right? You can accept anything that's a subclass or descendants. So that means this is okay. So phone number, so this is not okay, sorry. Phone number over here, yeah. It's always that you do something that's correctly, but you say it's completely wrong. The phone number here is not correct, because phone number here is string. And then you can see the string is not compatible with dates. They are not compatible. So it's going to be not compiling. Are we comfortable with this? Any questions? Are you okay? You're sure? Good. Yes. How 3? Oh, we'll get there. Don't worry, we'll get there. Actually, follow the same logic. We'll get there. We'll get there. Remember, every occurrence of G in the supplier has been replaced by dates for this particular clients. Remember, right? Let's go over. Let me just do 2. Okay. How about 2 over here? It will compile because now birthday over here is of type dates, and the date is actually compatible with the dates, so that is okay. Now, let's help you answer this question here. When we go to, let me change another color here. When we get to b.get UNA over here, so now in the case of the general book, let me just go very quickly back. When we said b.get UNA over here, it's going to return any. Remember? What about now? Why would I return dates? Yeah, because you want to see exactly the context object is actually B. For B, we already asked the client to commit to which element type is going to be for the collection. In this case, it's going to be dates. So that means when we try to say get, it's going to be dates over here. Okay, so this expression over here is going to be statically dates. So that's why it will compile. Intuitively, since we are now being much more selective on storing things into the collection, so when we return anything back, we can be so guaranteed it's going to be a dates.
Right. When you cast it, it's not cast.
You know what? Interestingly, you don't have to do cast anymore. It's guaranteed. Well, this is a much better design because now when you say b.get UNA over here is guaranteed if it compiles, whatever that's being returned must be of type dates or its subclasses. Thinking this way, let me put it in another way. What can cause class cast exception? If you try to cast maybe dates into if you try to cast string into a date, right? But any string objects even wouldn't get a chance to be inserted into a collection. For example, if you look at line number 1 over here, when you try to add in phone number over here, we say that it's not going to compile even, which would compile in the general book case, right?
So if you want to store different stuff without use.
Yes, correct. Yeah, the polymorphism we'll get in there a little later. Okay, basically, let me just make a mini conclusion over here intuitively. Since we allowed only date objects to be stored because we commit to the dates over here, what's returned, what's retrieved, how about that? What's retrieved from the book is guaranteed to be a book. Oh, sorry, it's guaranteed to be a dates. To be a dates objects, intuitively. Okay, you see, basically we're just trying to talk about generics from a different perspective rather than code reuse. We want to dive much more into polymorphism, dynamic binding, and cast. Generics is a really huge, major improvement over just having an array of objects. Okay? I remember when I first studied at York, in my second year, when I learned about Java course, we still talk about array of objects. As soon as I went to the fourth year, they released 1.4, 1.5, I forgot. And that version, they started to support generics. You can see there's a reason for the change. Otherwise, why bother, right? Guys, any questions? Yes?
The compilation rules for line 32 is static type phone number needs to be ancestor or descendant class.
It has to be a descendants. Basically, you're thinking this way. Good question. Basically, over here, you mean for 3?
Yeah.
Okay. For 3 and 2 is a little bit different. Okay, let's say for 3, since you asked about 3. So 1. Okay, no worries. Okay, let me write it down. When I say b.add, okay, I want to make sure it's readable. You know what? Let me use a better color. Okay, let's say if I say, talk about this line here, line number 1, b.add over here. I have some string name over here, and then I say phone number. Let's say PM. What's the compilation rule? In this case, since generics is in the place, okay? What we're gonna do is, it's really important to look at the context objects. the static type of context objects B. So what is the static type? It is exactly book dates. It's a book dates, which means it's basically the original book class, except that every occurrence of G is going to be replaced by date. Yes.
But I thought it was only had to be strictly descendant during runtime, or the runtime.
The runtime, no, at the compile time, it can be descendants.
What was it about like last lecture there was during compile time?
Yeah. Okay, sure, no problem. So let's think a little bit further, okay? I think it's a good question. Let me do this. Okay, let's say we got a class over here, book, G over here, and then let me just make a simplified version. If I have at over here, and then I have, let's say, name of type string, and also followed by our record of type G, let's say. And of course, you can do some stuff over here, okay? That's the supplier side. Okay, and then let's talk about the clients. For the clients, basically what we have is this. Let's say for the clients, another class. Let's say we declare B1 to be, let's give you two examples, how about that, okay? B1 and B2. Let's bring our student friend back into the place, okay? So let's say book of students versus the book of resident students, B1 and B2. Okay, so now we got B1 and B2. Basically, they're two separate client usages of the same generic class. So now we want to know, for example, let me try to test your understanding very quickly, okay? So now let's say we got, let's say S1 is of type students. S2 is of type resident students. S3 is of type non-resident students. Okay, that's a decoration for us. Okay, let's imagine that we already created a book. Okay, I want to ask you the following lines whether they should compile or not. Okay, and I'm sure it's going to strengthen your understanding. So now if I say b1 dot add, okay, you know what? For simplicity, I will just get rid of the first arguments. Just keep the record, okay, for simplicity. So now let's say I'll put S1 over here and B1 dot add. S2, B1 dot add. I got S3. And let me just repeat over here. B2 dot add. S1, B2 dot add. S2, and also B3 dot add. S3. You will find that basically, if you can understand exactly how the generic parameter G is replaced by whatever type that's being committed to, it all boils down into the feature argument polymorphism discussion that we had back in last week. Okay, but let's do it again. Okay, so now let me just number them. 1, 2, 3, and also 4, 5, and 6. Okay, so now, should one compile? Yeah, it should compile, right? Let's just go over all of them quickly and then we'll explain. Should 2 compile? Good. 3? Okay, now 4. Okay, good. 4, no, right? Okay, it's really critical, but I'll explain in just a moment. I want to test for everybody. What about 5? 3? Good, that's the right answer, but let's explain, okay? So now, in the case of 1, 2, and 3, you're basically talking about the context objects, really important. B1 is a context object for which you commit to student type, which means every occurrence of the G has been replaced just by students. So now we are back to our feature argument discussion, right? Given that for B1 is as if we declare students over here, so now the static type for S1 is simply students. Student is a descendant class of students, so that's fine, right? Similarly, S2 was declared of resident students. Resident student is a descending class of students. Okay, good. So now, if we move on to the second group, we talk about a different context object, which is B2, right? Different. It's actually B2. I'm not sure why I said B3 over here, okay? There's no B3, sorry. B2, okay? Just B2. So now let's talk about B2, and B2 was declared to commit to resident students. Okay? So it's as if we try to replace every occurrence of the G by students over here, resident students. Every occurrence of G by resident students and resident students. And now, when we judge for this particular line, so now S1, we know that the static type is students. Is students a descendant class of resident students? No. That's why it doesn't compile. Okay? Similarly for the other two. Okay? Guys, are you comfortable? Okay, good. Any questions? Are we okay? Yes. Correct. Yeah, correct. Well, this is so that's basically the same hierarchy we said before. In case you forgot, which is okay, students under which we got resident students, and we got non-resident student, right? So everything is connected to previous lectures. Okay, after this, let me see what else to be said about generics. Okay, everything else you can just follow very quickly. Okay, parameters, also I just try to explain to you what parameters really mean. You can also read through the slides quickly. Okay, this is just how the generic book will look like, and we also went through them. Okay, so now what I want to have is give you a little bit design tips. Okay. Okay, again, this slide here just explains which line compile, which line does not. We also discussed that already. Okay, so now I want you to consider this particular design. I believe you asked me this before the reading week. Okay, maybe you forgot, but I remember. Okay, okay. Has the following client made an appropriate choice over here? Basically, me as a client, or you as a client, you want to declare a book. I want to be so tolerant. I simply say, well, remember you can instantiate a generic parameter G to be any existing class, for example, right? Account is one example, student is one example, resident student is also one example. But now I say any. How is this design here? Is it poor or good? Why is that bad? Yeah, basically, a single choice principle, yes. Basically, if you say book of any, you're basically just like a general book. That means, again, anything that you want to store, as long as it's a descendant class of any, for which case, every class is a descendant class of any. So it's as if you say a general book. If you ever write things like this, that's really bad, right? Really, really bad. Yes?
Wasn't a better way to use a class that specifically tells you what you want to store?
Exactly. Again, remember when we talk about design choice for polymorphism, you want to choose a class such that you don't have to do so many casts in your application code. You want to strike a balance. If you have to do so many casts, that means you want to declare the type to be a little bit more specialized, so you don't have to do so many casts, right? Good. So now this is really bad. Okay? Hopefully I cannot emphasize this enough. It's really bad. Okay? Basically the idea is basically just allowing anything to be stored into the book so that anything can be retrieved. Okay? Yes.
I understand that this is bad for violating single choice principle.
Mm-hmm.
But if we use generics, then isn't it too much work for the client? Like, if there are 100 items types, then you will have to maintain 100 instances of book.
Oh, think it this way, yes. So I talk about this particular example over here. You mean the book of any, or you talk about generics in general? Generics in general, right? So let me try to see if I understand your question correctly, first of all. Okay? Let me just start a new page. Basically, what you're asking is, given that the supplier has a book of G over here, that's the supplier, okay? And then you got the rest. So that's the supplier. From now, for you as a client, the only burden you have is every time if you want to declare B of type book, if you simply write something like this, it wouldn't compile. The compiler is going to say the class you're using is expecting G to be instantiated, but you haven't specified that. That's the only burden. However, as soon as you specify some class over here, for example, students, as soon as you specify a class over here, everything will be done by the compiler for you. Which means every time when you try to say b.get, where you say b.add any feature, the compiler is going to check for you whether or not the stuff you get into or get out of conform to this particular student type. That is something you have to do using a cast or instance of check if you got a general book. So that's really the advantage. Okay, thinking this way over here, if you think about general book versus generic book. So if you talk about the clients, let's say for the clients, okay, the client side. In the case of general book, it will simply say b declare that to be a book. On the other hand, you're going to say b book, and then over here you're required to say something over here, some type. Okay. Second thing, if you say b.add, if you want to store something into it, basically anything will be possible. I'll just say star. Okay, anything will be okay. On the other hand, if I say b.add in the right-hand side, it has to be something that is consistent with the type you commit to. Okay. Similarly, when you say b.get, you're going to retrieve something out. Okay, something over here. So now in the case of the general book, this will just be any. So that means you got to do some cast. That's where the danger, that's where the inconvenience is that will violate single choice principle. On the other hand, in a generic book, if you say b.get, it's guaranteed whatever you return is going to be exactly this type. Because it being so selective in storing things, it's guaranteed to be more safe when you do things retrieve out. Okay? No cast will be necessary. Okay? Does that answer your question maybe? Yeah.
This puts more work on the client. So again, you could use a collection. Suppose if there are 3 types, student, resident, and non-resident. You could use just only one collection, and we would worry about if you could call this method or not in the supplier side. But now client has to work on it.
Yes. So in some way, well, think about, it's more like a trade-off. In some way, the extra work the client has to do is to choose a type for the G. What they really get rid of, what the client doesn't have to do is the instance of checks and also the cast. That's something the client doesn't have to do, right? You'd rather avoid the latter rather than the former. Okay. Yeah, good. Guys, any questions? Are we okay? Okay. A few more slides to show you a little bit more design choice, and then we are done with this particular lecture, and then we'll go to the design pattern. Okay. Okay. So now let me go back here. Okay. Okay, that's about instantiating generic parameter. Let's do a little bit of exercise quickly, okay? I just want to give you a little more example over here. Okay, it's exactly what you see in the slides. So now I want you to be a little bit more careful whenever you use the generic parameters, okay? So let's say for the supplier, we have a dictionary class, and then it has 2 generic parameters, one for the value v and one for the key k, v and k. By the way, b and k, we can use them as generic parameters because they do not clash with any class names at the moment, so v and k. And then we can use them systematically in every place that we wish. For example, when you say add entry over here, I'm saying whatever v I commit to from the clients, I'm going to use v over here. And whatever k that the client commits to, I'm going to use k over here, etc. Okay? Similar idea, just 2 generic parameters rather than 1. Okay, that's a supplier. Let's do a very quick exercise to make sure you understand this stuff. Okay, let's say now we have a client class called database table, let's say. Okay, basically database is going to somehow use the dictionary as an implementation, let's say. Okay, so now one thing I want to show you, the order of the generic parameters is arbitrary. It's up to you as a designer how you want to organize them, as long as you're using them in a consistent way. Okay? What I meant by this was, you can see over here, I want you to look at these 2 class declarations. So class dictionary, vk, and also class database table, kv. You can see vk and kv, right? And now, When I have this particular implementation attributes, I simply say dictionary vk. Okay? What does that mean over here? Okay? Are you okay with this? This is a little bit trickier than what you do in the labs. I just want to show you a little bit more what you can do in practice. Okay? Because sometimes the client might be more used to having the value first before the key. Sometimes it might be the other way around. You can choose whichever way that suits your need, as long as you use them consistently. For example, I want you to consider this. So now we got two classes over here. Let's say dictionary. We also got database table. Okay? My question for you is this. Let's say I'm going to use this particular database table class, let's say. So I simply declare database table, and of course I will be obliged to instantiate k and v. I simply do integer and string. Okay, integer and string. So now, question for you. If I have a database table of integer and string, what would you do under the hood? What would that instantiate a dictionary to be? Integer. It's quite obvious, right? I hope, okay? Because integer is now going to be the k, and string is going to be the v. And k and v is just going to be used in an opposite order, okay? That's definitely fine, okay? So, that's one way to use it, okay? Another way to use it would be, I want you to show you, okay? Let's see over here. What about this guy here? Let's say we got student book over here, and then we simply say v. In the previous case, in the database table, we got k and v, and we simply give the two generic parameters inside. But now we're being a little bit more determined, which means for me as a client for student book, I don't worry about the key type. It's always going to be a string. But for the value, I might got something different, right? So that's why I leave the v to be open over here. So you can see the difference here. So here we got two generic parameters, but over here we got only just one, because we fix the key to be just a string. Okay? So now, very quick exercise for you. If I declare students over here, student book, to be array of course. Okay? So now, what would be the corresponding dictionary that's being used? It's going to be array of string. Is the first one or second one? The first one, right? Because whatever v I pass over here is going to be used as the first one. It's going to be array of string, and then a string. Okay? That's how it is going to be instantiated over here. Like that. Okay, the way you use the generics is completely up to your creativity, right? I'm just showing you two of them, okay? Okay, I think I just got two more slides to show you, two more. Okay, what I want to conclude the generics by is to bring inheritance into place, okay? So now I want to, how about this? Let's just say this one here. Okay, I'm gonna show you on the iPad too. This is how you can think about generics versus inheritance, okay? One is horizontal, the other one is vertical, okay? So now, basically inheritance allow you to going from more general to more specific. The descending classes are always more specific than the ancestor classes. On the other hand, for generic parameters, you're basically saying, for this particular element in the collection, I simply don't want to commit at the supplier level what they should be. I simply parameterize them out, okay? So now I want you to look at, in the vertical direction over here, I may have a set, I may have a list, which is more specific with the ordering. I may have a linked list, which is even more specific with the link structure, right? So you can see these are more abstract, these are more specialized. So that's inheritance. Okay? And each one of them may just be parameterized with the generics. That's a vertical direction. Are you okay with the vertical direction here? So you can see I have set, I have list, I have linked list. The lower I am, the more specialized I am, the more concrete. Okay? What about horizontal? Horizontal basically is for a given particular class, I can parameterize the element type to be any type I like. For example, let's say here, you can see here for the list of books of G. Okay? So now once I declare the G to be parameterized, I can instantiate G to be different types. G can be instantiated to be people. It can also be instantiated into journal, or to be a list of accounts, a list of maybe binary search tree, etc. So that's the horizontal direction over here. Guys, are we okay with this? Okay, that's how you can think about inheritance versus generics. They are not really depending on each other, but they work together. Yes?
The horizontal axis is not really a scale.
It's not really about, what do you mean scale?
Because it's up and down, like you get more specialized.
Oh yeah, correct. The horizontal, basically, you can think about horizontal means the same block of code. It's just that from one class to another in the horizontal line, for example, if you go from list of people into list of journal, let's say, the element type is different. However, the block of code for the logic is just the same. You just replace the G, in one case by people. In one case, you replace G by journal. Right? On the other hand, when you talk about set versus the list, they're different. Right? Set has no ordering, list has ordering. Right? Okay, that's one way to really see the difference between inheritance versus generics. Okay, but I would say maybe in your projects, you may want to have both in a way that makes sense. Okay? For example, when you read about the undo redo pattern in OSC chapter 21, you got lots of instance for the inheritance. Okay? Guys, have you started reading? I hope you do, right? Please. Okay? Because I'm not going to take the lab test, you will, right? Next Friday, right? Please, read it. All right. Any question about generics so far? We're okay, right? Good. Let's now, basically, we kind of finished the basics about inheritance, generics, polymorphism, and unbinding. Now we're going to have a serious design patterns to challenge us. Basically, more like an application. Okay? We adjust the order a little bit. Usually, in the previous semester, we did the state pattern first. But now we swap the order because lab number 5 is going to be about the composite and visitor. So that's why we'll talk about these two patterns first to get you prepared for lab number 5. Okay? Let's talk about the composite design pattern that will form the basics for the visitor pattern, which hopefully we'll at least start talking about it on Wednesday. But hopefully on Monday, I will finish the two patterns. Okay? The visitor pattern is the most interesting pattern, I think, for this course. You got lots of interesting phenomenon for polymorphism, dynamic binding, both in the compiler time and also at runtime. Okay, that's something we'll get into. Let's talk about composite first. Okay, let's go over a little bit more slides here. So the motivating problem. Every time when we talk about a particular design pattern, we want to see what kind of problem can we solve by using this pattern. But I don't really give you the solution right away. Let's consider other alternative solution first before we talk about the actual solution. Okay, that's why it's a really good discussion. What's the motivating problem? Let's say we talk about some manufacturer system for computer hardware. Okay, let's say the person lab want to refurbish their equipments. Let's say, so basically we want to have the computer system for the equipments we want to buy. There are basically two categories of equipments over there. One is called base equipments. A video card, maybe hard drive, mouse, keyboard. So these are the base components. And we also got something called subsystem or recursive components. Subsystem in the sense that they can contain other equipments. For example, you might buy a chassis which can contain hard drive, video card, etc. You may also buy a cabinet which can also contain other computers, to store for the main server. Okay, so I got two notions of components. I believe I got a diagram over here. Okay, so here, I'll see the diagram in just a moment. So basically, you have individual equipments. You got hard drive, you got CD-ROM or DVD-ROM. And also, for each component, you got some properties you want to calculate eventually. But we're going to focus on, for example, you can have power assumption and also cost. Eventually, what we want to do is, we want to have a shopping cart of various equipments. And we want to have a very effective way of aggregating the prices That's what we want to do. Okay, we'll see that. Okay, but price is the problem we're going to solve. Also, you got composite, or they also, well, sometimes I say composite, sometimes I say subsystem, sometimes I say recursive component. They really are used interchangeably. Okay, composite. And we got cabinets, we got buses, we got chassis. Okay. Okay, each one of them might contain other components. Okay. So now, the thing is, we want to design a system, classes, features, commands, queries, such that we can easily build the hierarchical structure for the components. I'll show you a diagram in just the next slides. And then we want to have a very efficient way to calculate the cost for the equipment. For example, let's see one diagram over here. Okay? So now you can see that it's hierarchical in the sense that you can see the top level is like a top-down structure. It's not circular, it's a tree. It's not a graph. So now there's a cabinet over here under which we got 2 chassis, and also we got 1 power supply. You can see power supply is a basic component which does not contain any further components. On the other hand, the chassis is actually composite, it's recursive. Chassis, the first one, contain the card and the hard drive. And the chassis itself may contain another chassis, for example, right? And the chassis, the second one, contains the DVD ROM and also hard drive. So now, question is, let's say eventually, if I have an object called C. C is this particular cabinet object. If I say C dot price, it is going to give me the aggregate price of all the subcomponents under this particular cabinet. That's the problem we're trying to solve. Does it seem to be an easy problem for you? No? Good. That's why we're learning the composite pattern, right? That's good. If you think that's easy, what's the point, right? A very naive solution, very naive, right? You can simply just go to, say, every component there has a price feature. I can say C dot price, adding with C dot price, adding C1 dot price, C2 dot price, and power supply P dot price, just kind of do it explicitly. No, that's not how you want to do. Because a tree structure can be arbitrarily complicated. Oh, say it again. Well, somehow you want to use a recursion, yes, somehow, yes. But somehow your structure itself better be recursive, easier for you to actually run the recursion. So the question is, how do you design recursive structure at a class level to support this? Based on inheritance, I like that. Yes. How exactly is that? Right, that's something we'll get into, don't worry. Okay? Yeah, actually, what we're going to see is not only that we're going to use inheritance, we're going to have something called multiple inheritance. Multiple inheritance, yeah. I'll try to make this discussion very narrow because multiple inheritance is a huge topic. I'll just show you the ones you need to know. There's some particular issue about multiple inheritance you want to avoid. I'll give you a little bit of hints over here, but I'll talk about if we have time at the end. Okay? I'll just mention the one you need to know. Okay? And then have some example. Okay, let's go for that. The challenge is your design must be able to clearly distinguish between base versus recursive component. That's the key. Okay? Once we get a composite sorted out, we can go ahead, talk about a visitor, which will be how to visit or traverse the tree in a way that's going to be very interesting. We'll see. Okay? But that's something we're going to see later. Okay, I want to show you some very quick diagram over here. Basically, no, sorry, not here. So multiple inheritance, the principle is very easy. Whenever you talk about multiple inheritance, it simply means a class may have 2 or more parent classes. By the way, Java does not have multiple inheritance. In Java, you can implement from multiple interfaces. But remember, each interface contains signatures or headers for the methods only. There's no code. But in IVO, at the design level, you can inherit from multiple classes and also reuse the code from the parents. But the only issue you have to be careful about is you might have clashes. Okay, but that's something I'll talk about in just a moment. Okay. Again, as I said, multiple inheritance is a big topic which I'll just mention the thing you need to know in order to understand the composite pattern, first of all, to begin with. Let's not be too ambitious in the beginning. Okay? So now this is just one example over here. For example, you can see that's just for the Eiffel library. Okay? Over here you can see integer is both a comparable, you can definitely compare between two integers, and also it's also numeric, right? It's a multiple inheritance. Similarly, you can see over string is only comparable but not numeric, right? And also double is both comparable and numeric. And complex number is actually numeric but not comparable. Okay, things like that. Okay, just one example here. I do want to challenge you a little bit more. Okay, that's something. Okay, that's the next one. That's about, now let's try to solve this problem very quickly. That will give you the insight into having a composite pattern. Okay, let's do this one first. Let's say this is what I would like to achieve. Okay, I basically want to have a list of windows. Okay, each window might be of different size and at different coordinates. Let's say a two-dimensional plane. Let's not talk about 3D, just 2D. Okay, for example, you can see that this particular blue window over here is contained within the yellow window. Let's go bottom up. How about that? You can see the orange one is the smallest one, which is contained within this green one. And also the orange one together with the green one is contained within the blue one, right? And etc. Which means we're talking about the following design. Each window has a list of other windows, right? Also each window has its own attributes or properties, okay? So what I would like you to think about a little bit before I show you the code. How would you design classes to really support such construction at the runtime, okay? To really put one window under another, okay? Recursively. So the nested level for the windows can be arbitrary, can be as deep as you may wish. So now let's say we got different properties for the window. We got height, we got width, the dimension. X position, Y position, we can change the width, change the height, move. And also we talk about parent window. For example, you can see that. Let's just have a look at this particular instance. Let's say the orange and the green. I would say the orange window has the parents, the green window. Right? The green is the parents of the orange. And also we also got descendant windows. That also makes sense because in some way for example, the blue one over here has no descendants, right? On the other hand, the green one has one descendant. What about the yellow one? This one here. How many descendants does it have? Or just count, right? Just count. Well, for example, 1, 2, 3, 4, 5, 6, 7, 7. Okay. Okay, something like that. So now I want you to think a little bit more. The reason I put hints over here is how many, every time you want to design your classes, let's say for your ETA projects, you're basically classifying entities, right? So now I give you hints about what properties you want to support for the window entity. But now, how many classification do you think you will need in order to divide these features into? Just one single class? 2 classes? 3? 4? You think 2. Anybody else? I can tell you that in this particular case, having a single class might work, but it will suffer from 2 drawbacks. Number 1, it's going to be a Superman class, which means you put everything together into one class, which may not be so relevant to each other. And number 2 is something we'll see a little bit later. Okay. How many classes? I heard 2. Okay. Anybody disagree? Should you think 1 is not good? Okay. Should it be more than 2? Okay, if you say 2 classes, which 2?
So first one will be for functions. Second one will be specifications.
What do you mean functions versus specification?
So change width, change height, move, this is called.
Okay, so let me see if I really understand you correctly, and let me start a new page quickly. Okay, are you trying to tell us the following? You're basically saying you're going to have maybe one class over here and the other class. So here, maybe change the width of the window, maybe change the height of the window, and also here you might have the parent window, you may have the descendant window, and also, sorry, just descendant window, and also you got maybe the width, and also the heights. Basically, anything to do with commands, you put in one class. Anything to do with maybe getting some queries, you put in another class, right? That's what you meant? Okay, that's one possible answer. C1 and C2, let's say. Anybody disagree or agree?
I just had a different idea.
You have a different idea. Okay, how about I take Ken's idea first? Okay.
It's the optional class that has everything except for parent, and then like a child window class that has the parent attribute.
Okay, so let me just try to draw that very quickly. You're saying, okay, how many classes? 2 classes? Okay, let's say, are they, do you have any inheritance over there?
Yeah.
Okay, let's say we got C1 and C2.
C1 has everything except for parent.
Except for parents.
Yeah. C2 just inherits it and it adds parent.
I see. Okay, I see what you mean. Oh, interesting. That's interesting. Okay, basically here you got parents, of course here you got descendants. And also here you got basically, okay, so here you got maybe heights, you got width, and also you got, let's say, change width, change height, etc. It's very interesting. Okay. Okay. Anyone else? I'll come to that in just a moment. Okay. I'll leave that aside. Yes.
If you want to split everything to do with the hierarchy, so parent, descendants, all those in one, and then have a class which goes that way.
Okay. So now basically we got 3 different designs, right? Design number 1. Okay. Design number 2. Okay. Design number 3. Okay. Design number 3, you basically talk about also 2 classes, which have nothing to do with each other, right? Okay, maybe 1. You only got maybe something to do with the dimension with the window itself. You might got heights, you got width, you got change the width and change the heights. And another one more to do with hierarchy, as you said. Maybe the parents, and also you got descendants over here. Okay, that's fine, that's fine. Okay. Now, D1, I'm afraid, may not be as good as the other 2. That's okay. No, it's good to think about it. D1, because simply just separate the classes in terms of which one is commands, which one is queries, not the way to go. It's nothing to do with the meaning for the features. Okay? We want to really see what's the meaning behind the features. Otherwise, for your ETF project, you just have 2 classes too, right? All the commands go to one class, all the queries go to the other class, right? Okay, so this one, I will just put a cross mark for now. Okay, it's not as good. Now for D2 versus D3, let me criticize a little bit on the design number 2. Okay, if you think about design number 2, basically the concept about basic components and recursive components is still not very clear, not exactly clear. Okay? Because over here, you can see, because there's an inheritance over here, so everything from C1 will still be inherited to over here. So you're basically having 2 classes that looks just like the same, except that for this class, you just don't have parents, but the other one, you have parents. It's not exactly giving, you know what? Let me leave this design aside. Maybe we'll try to go there once we see the final composite pattern. Then we'll try to criticize a little bit further. Okay? It turns out D3 is much closer to what we want to have. Okay? Okay? So this one here is more about hierarchy. Okay? This one is more about the normal attributes for the components. Okay? So now we want to see exactly how we're going to turn these into composite design in a moment and see how multiple inheritance can be helpful. Okay? Let me show you the code very quickly to get an idea, and then we'll move on to composite pattern. Okay? So now let me show you the code over here. You know what? Let me show you the slides very quickly so we can see one class by another. First of all, let's have rectangle. So that's just the normal rectangle. So here in the rectangle class, there's no concept about hierarchy. Nothing about parents, nothing about descendant windows, nothing. Okay? Rectangle, each rectangle has a width, has a height, has coordinates. You can make a rectangle, change the width, change the height, and move. Okay? you got another class that's called a tree. Okay? And notice that it is generic. Being generic is a very good design decision here because we don't constrain G here to be just rectangle. So this class can be reused for other purposes. You may want to have a tree of students, a tree of person, or a tree of accounts. Okay? So we keep it as flexible as we can. Okay, over here you simply got parents, you got descendants, also you got add child, etc. Okay? I won't go too much detail into this particular code, but it will give you some intuition about the composite. And then now here comes the important thing. How can we combine these two different concepts together into a single class? Well, since we talk about design, the multiple inheritance would be a very good choice. We simply say the window is simply just going to inherit two classes. Okay? So this is our first time seeing multiple inheritance. You might do something similar in Java in the sense that you can say rectangle is an interface and tree is also an interface. You simply say window inherits from the two interfaces. That's also possible, right? Now, let's see this. So you have a rectangle over here, and for tree, for this particular case, it's going to be a tree of window. Right? You can see I instantiate G over here by just window. Okay? And I'm also going to have add feature. I can add some window into there. Are we okay with this? Yeah, just take some question previously.
What's the benefit instead of having a generic insert or restore G, only store the value of G? Is that like having a composite tree is composed of?
Yeah, basically tree is more than, like as you said, a hierarchical concept. But now we want to be very general here. We don't want to constrain the G to be rectangle only.
So we could store G, the generic G, as the value. I have a tree called value. I'm like, do it for tree store.
Okay, let me try to see if I understand you correctly. That's the same block of code. Are you trying to suggest rather than having G over here, you say rather than this?
Rather than making a window with double one curve, now if we have a client supplier relationship between rectangle and tree, where tree stores G, it stores it again.
What you're suggesting is something like this. You want to say the window class, okay, let me write it down for instance, interesting. You're basically saying something like this. Let's say I have my window class over here. Sorry. So the window class is still going to be a descendant of rectangle. Like that. Okay, and then over here, you're just going to have a client supplier, as you said. Let's say window is going to have a list of windows, right? Let's say descendants. Okay, just let me know if that's exactly what you're saying. Descendants, and then we're going to have something, let's say a list of descendants. Okay, let me just write a little bit more appropriately. So this one is going to be a list of descendants, right? Okay, window is going to be, oh actually, sorry. What am I trying to do? Just descendants. That's all I meant to do. Beg your pardon. That's simply just going to be descendants over here. It's going to be a tree, right? So tree is going to be G, and then of course you have the feature something like parents, descendants, and add child, right? No problem. Okay. Okay, you got value over here. Also you got parent, child. Okay, that's what you're asking, right? Okay. Value is going to be a rectangle. Rectangle. Is that what you're suggesting? Okay, and tell you what, it might work at the runtime, but it's not as intuitive in the following sense. Basically, what you're saying over here is, you know what? Again, it's interesting. I need to just get this prepared. How about this? I'll leave this page here. I will come back to this design in the beginning of Wednesday. I think that'll be better. Okay, good. For the moment, can we just go back to this particular one? Okay, and then I'll come back to your design. Okay. So now, over here, what you will see eventually is, if you want to be as a client for the window class, what you will have to do is to say you can create a various window over here. You can create a window W1, W2, W3, W4, etc. Okay? So now you can say for W2, okay, let me just draw them very quickly. Basically, you may have W1 is now pointing to some window. Let me just give you one example, just for, as an example. Let's say when we talk about this particular feature call, right? So when we first create W2 and also W4, okay? So when you create W4, it's just going to be a rectangle that looks like this, okay? When you create maybe W2, it's just going to be another window like this, okay? What we wanted to happen at the runtime, when you say W2 is adding this particular window, you just basically want to say this is going to put inside this particular window. It's one of its descendants window. Basically, that's what's going to happen. Okay, but I'm not going to dive into the details for this just yet, because we're going to see composite design first before we can get there. Okay. Okay. So this slide here, don't worry, we're going to revisit multiple inheritance for sure to see exactly how it can be used in the composite pattern. So now, before we do that, okay, I want to show you one more thing about the number one common error you might run into for multiple inheritance. Okay, so now I want you to tell me, let's say this. Basically, let's consider this particular multiple inheritance. We have two classes A and B, for which each one of them we got the feature foo, the same name. And now we got a multiple inheritance over here, we got C. So now, any problem do we have? Well, name clashes, right? It's actually in the title there. Which means now, in the context of class C, whenever you say, I got a static type C, when I say that object are foo, which one am I referring to? Am I referring to the foo from A or the foo from B, right? So we need to have a way to disambiguate, okay? One way to do it, well, actually, the only way to do it is to do some renaming, okay? Okay, basically, the renaming will look like this. What you gotta do in IFO is you can say C inherits A, and then you rename the foo from A as fog. And then I'm gonna rename the food from B into zoo. That's what I'm doing here. Yeah, I'll take question first, and then I'll, yeah. Are you okay?
Yeah, how does he know which code you rename?
Yes, okay, let's see this. So you may want a little bit code over here to help you, okay? Okay, let me just go to the next one. Oh, exactly here, good. Okay, so now think about how you're gonna write this. Okay, I'll write it exactly how you're gonna write in iPhone. So now when I say class, let me just write a little bit upper so like more space. If I say class C, okay? First of all, I'm gonna say inherits A, and also eventually I'm gonna say inherit B. If I only do that, I'm gonna have name clashes. Now I want to say, when I inherit from A, I'm gonna inherit this particular food. For that particular food, I'm gonna say rename. Foo, so rename is a keyword. Foo is fog. And similarly, how do I deal with this particular foo from B? So when I say inherits from B, I'm going to say rename. Okay, also a keyword, and then I'll say foo is zoo. Okay, that's how you write a syntax. Well, it makes sense, right? You just have to know the syntax, okay, for your projects. So now, let's do a very quick exercise over here. So that simply means, I'll get to you. Yeah. You can just rename one, that'll be okay, yes. If you just rename one, that means foo will be available to a particular subclass, right? The particular, yeah, just from the particular parent class. Yes, but I'm just doing both, yes. You can definitely use, as long as you don't have name clashes, okay? So now, let's do some very simple exercise quickly. So now, that simply means, at the level of A, we have foo. At the level of B, we got foo. Now at the level of C, foo doesn't make sense anymore because both instances of the foo has been renamed. One is called fog, the other one is called zoo. Okay, let's see very quickly a table. Okay, now expectation, right? Okay, so now let's say we got object O of static type A. Can I say O dot foo? No, A. A, right? Okay, good. Okay, now what about O dot fog? No, right? Fog only exists in the subclass. What about O dot zoo? No. Good. That's the first one. Static type. Only look at the expectation. What about now I change the static type to be B. So now can I say O dot foo? Well, are you sure? Are you sure? Good. Okay. It's always to be sure, right? When I question you, I might be wrong, right? Yeah. Now, what about when it's static type C? Can I say O dot foo? Why not? It's being renamed, right? So what will be available now? O dot fog and O dot zoo. Exactly. It's very straightforward. Okay. So now I'll pause over here. From Wednesday, I'm going to talk about your design first to begin with, to criticize that a little bit, also Ken's design, and then we'll move on to composite pattern. We'll finish that for sure on Wednesday, and then we'll start the visitor pattern.